Okay, welcome to the Falcon All-Weather Industrial Motion Sensor webinar. Today's presentation, the objective is the Falcon Family, technology, features, applications, adjustments, wiring, and common installation issues. Falcon Family. The Falcon, the standard Falcon, mounting height 11.5 to 23 feet. It's for use in indoor, outdoor applications, clean rooms, cold storage facilities, watchdown facilities, also in areas for harsh environments, random traffic, architectural features, and changing temperature and backgrounds. FalconXL, mounting height 6.5 feet to 11.5 feet. It's available for applications where the sensor needs to be mounted lower and provides a wider detection field. Same conditions for use in these areas as well as harsh areas in here, the XL, as well as the Falcon Wide. Mounting height 11.5 to 21 feet, provides the widest detection field. And then we have the Falcon explosion-proof housing. This is actually a housing. Falcon fits in it. NEMA 4 waterproof rated enclosure, designed as IP66 housing, and has the other UL classified division and group compliance ratings for explosion proof. In technology, microwave radar, the Doppler effect principle. Radar strikes a moving object, microwaves are reflected back, and their frequency is shifted in proportion to the speed, size, and direction of the object. Emitting microwave here. The Falcon motion sensor detects motion utilizing K-band microwave technology. The Falcon has the ability to understand the direction of the motion and can discriminate between pedestrian and vehicular traffic. We emit the Doppler radar, bounces off of an object, shifts the frequency back to the sensor. One of the ways we tell the difference between a vehicle and a person is the vehicle is moving on a smooth linear plane like so toward the sensor, so the shifting of the frequency will be somewhat consistent, whereas a human, we kind of bobbling up and down. It's going to be erratic shifting of the frequency deflected back to the sensor. Doppler radar continued, a technical kind of view of the Doppler radar. The transceiver, if this were the face of the Falcon, have a transmitter and a receiver. Transmitting the Doppler radar to the target and receiving it here on a wave shifted frequency from a target passing through the object. You see it has one particular wave, maybe the transmitter, and the shifted frequency based on deflection off of the target would be a different frequency. Frequency divided by the target speed divided by the distance variation, you equal the shifted frequency at 45 hertz here. So the minimum and the maximum basically would be these two frequency shifts here. I'm not going to go into anything else here. Well, we do have another sense you might be familiar with. Eagle gives a similar comparison on frequency shift from a low to a high, basically, and how it correlates to feet per second or miles per hour. So 12.4 miles per hour for the Falcon, feet per second is 18.25 per second. It's pretty quick. And the Eagle, in this case, 5.6 miles per hour is 8.25 feet per second. Be the maximum. Normal walking speed, when we determine human walking speeds for motion sensors, we typically try to use 3 feet per second. So that's much slower. This is geared to work on traffic vehicles, forklifts. And microwave motion sensor, the ability to disregard pedestrian and parallel traffic, 3-directional detection settings, ideal for harsh environments. Installation, mounting height, already showed in the previous screen, the Falcon at 6.5 to 23 feet, the XL at 6.5 to 11.5, Falcon Wide, 11.5 to 21 feet. Adjustable pattern shapes and sizes. It's powered off of 12 to 24 volts AC or DC. That's a range, so it could be 14 or 16 or 18 volts. Operating temperature minus 22 degrees Fahrenheit to plus 144 degrees Fahrenheit, and has a NEMA 4 enclosure. Falcon pattern shapes. Here in this example here, Falcon, standard Falcon at 11 feet. The tilt angle of 30 degrees gives an approximate shape or size of the pattern based on the 3 different sensitivity levels, 9 being the maximum sensitivity, and then we have 6 and 3. Kind of see the difference of the size of the pattern based on the sensitivity. And then the same Falcon mounted at 16 foot, same 30 degree tilt angle, showing pattern shape, size based on 3 sensitivity settings. Quite a bit of difference, mainly because the mounting height, 16 feet compared to 11 feet. Down here, Falcon XL, low mounting. It's going to give you a wider pattern here at 8 feet. And again, 3 different sensitivity levels. Looks like maybe, what do we have? 3, so a little over 12 feet might be the detection area. And the depth maybe, let's say 8 foot or so, maximum sensitivity. And then we have the Falcon Wide. This is showing an example at 11.5 feet. Very wide pattern here. Looks like, yeah, could be a total 18 foot wide zone. And again, 3 different sensitivity levels, or actually 1 sensitivity level, 3 different angle tilt adjustments, so you can see how the shape of the pattern changes as you move the tilt angle from 15 to 45 degrees. Falcon Environment. Survey the area surrounding the door for objects that may move into the sensing field or metal objects that could reflect microwaves. Here, got an example of a large fan that could cause some issues. Keep in mind that some obstructions may not be operational or moving at all times of the day. Here it looks like we have a conveyor belt system that potentially could cause an issue. Falcon mounting location. All directional functionality is in relation to the sensor face. Approaching traffic may be detected as cross traffic if mounted incorrectly. Obstructions may not be present at the time of the site survey. A goalpost or bollard could be added later. For proper pedestrian rejection, the Falcon should be mounted to the center of the opening. The Falcon mounted at 8 foot will have difficulty with rejection of pedestrians. The Falcon XL would be needed at 8 foot mounting height. And this is a perfect example of a poor mounting location of a Falcon here off to the side. I don't know how it's going to detect or even discriminate between pedestrians or vehicles. It would need to be mounted here in the middle to get good pedestrian rejection if they wanted to use it that way. Even if you wanted to use it just as a standard motion sensor, I think there's potential for erratic behavior. Mounting here, you got to look kind of behind the goalpost here. Falcon angle adjustment. Adjusting the angle changes the shape of the pattern. Increasing and decreasing the sensitivity affects the size of the pattern. Here are a couple of examples of the angle adjustments. 15 to 45 degrees, changing the angle here changes the shape of the pattern. Kind of a teardrop here at 45, and then we have more of a slight oval at 30 degrees, and then completely different at 15 degrees. And then if you were to adjust the sensitivity, these shapes would simply shrink or grow. Falcon field adjustment. Most installations require only 2 parameter setting adjustments using the universal remote control. Sensitivity, here, or discrimination, which we also call pedestrian rejection or vehicle only detection, here, which are these two buttons on the remote control. If you're unsure of the settings and would like to start the adjustment setting with a clean slate, then it's recommended to reset the Falcon to its factory settings. We'll show you that in a minute. Parameter change. All adjustments using the remote control start by pressing the unlock button. Press the unlock button. The sensor should be blinking red, red, red. Select the parameter that you wish to change or query. So we press unlock, it's blinking red, and let's say we want to ask a question on the sensitivity. We're going to press unlock, then press the sensitivity button, and the query parameter, press the question mark button. So we'll unlock, press the sensitivity, press the question mark, and then you count the number of green flashes that will equal the parameter value. For example, I know that the default value of sensitivity is 7, so unlock, sensitivity, question mark, you should see 7 green blinks if that's still the default setting on the sensor you're asking the question to. To change the parameter value, is press 0 through 9. So unlock, sensitivity, press say 5, and then to finish all adjustments by pressing the lock button twice, lock, lock. This will ensure to save your settings. So unlock, sensitivity, press a new value, say 5 in this case, and then lock, lock to save that setting. Go back in if you want and query the sensor and confirm that you actually did change it. Simply unlock, sensitivity, question mark, and in this example, I think you'll see 5 green blinks. Falcon parameter change, sensitivity, usually used to determine the pattern size of the microwave detection field. The rejection mode or detection filter determines the mass of the object required to cause a detection. This would be the button that you would use to set up vehicle settings. The default value is 1, maximum up to 6. The larger the number, basically the larger the vehicle or larger the mass that the sensor is looking for. The detection mode determines the direction of the object must travel to cause a detection. We can set it for detection of traffic moving toward the sensor or away from the sensor. Relay hold time determines how long the sensor will remain in detection after movement has stopped. Keep in mind this is a motion sensor. If you stop movement or if there's a static object, it will not be detecting it. Falcon parameter change. Continued relay configuration changes the relay state of the sensor. If you want normally open or normally closed, you can change that. The default values restores the factory default settings to the sensor. Simply press unlock, and on the bottom right of your remote, we call that the magic wand or the setup key or setup button. So unlock, magic wand, 9 will restore the sensor Falcon to default. The remote control is ideal for sensor security and or when adjusting 2 or more Falcons within close proximity. This prevents unauthorized persons from adjusting the sensor. If you had 2 sensors reasonably close or back to back, not back to back, but one in front of another, you were going to go under 2 doors, and one sensor can be inadvertently programmed with the remote. You can set an access code into one of them so you can't program it by accident. So to save an access code, we press unlock, and we press the lock button 1 time, and then a 4-digit code, and then lock, lock. So the next time someone has to program or wanted to access that sensor, they would press unlock, and then the sensor would blink real fast, rapid red, 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 and it will be expecting you to punch in that 4-digit code that you programmed it with. To delete an access code, unlock, press the 4-digit code, press lock 1 time, and then 0, that'll clear it to nothing, and then lock, lock, and then you can just simply unlock it and go about doing whatever you want. If for some reason there's an access code and you don't know what it is, And you usually know there's an access code when you press the unlock button and the sensor flashes really rapid, fast red flashing, red, 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 red. You can't access it, you can't do anything, it doesn't change the flash rate at all. That means you've got a lock code, and if you don't know it, you have to cycle the power on the sensor, so remove power and then reapply power to the sensor, and then within 1 minute after restoring power, simply go in and press unlock, and then press lock 1 time, and then press 0 4 times, and that will clear it. Lock locked as well. So unlock, lock, 0 0 0 0, lock lock. That will clear the code, and then they'll remove the access code and be good to go. Falcon push buttons. There are push buttons here and here on the sensor. As an option, manual push button programming is possible. Start and end adjustment session, press and hold either push button until the LED flashes or stops flashing. The red LED flashes are the parameter. The green LED flashes are the parameter value. Scroll through the parameters momentarily, press the right push button. To change the value of the chosen parameter, momentarily press the left push button the number of times you wish to change its value. In this example, to change the rejection mode from 1 to 4, you press the left button 3 times. So you would see a number of red flashes. I believe the rejection mode is 3 red blinks, that's the parameter, and then 4 green blinks would be the value of that parameter. So the red blinks is the parameter, and the green blinks is the parameter value. To reset the factory values, press and hold both push buttons until both LEDs flash. Falcon wiring is pretty straightforward, however we have a lot of confusion at times. Red and black are the 2 wires required for power. If you do nothing else, if you bring power to red or black, say if you have 16 volts DC, you put plus to red, minus to black, the sensor will light up. It'll be powered. You have 2 conductors for 24 volts AC. You're going to put 1 to red and 1 to black. The sensor will be powered and lights will flash. The sensor output or the relay output of the sensor are these 3 wires, white, green, and yellow. White is relay common, green is normally open, and red normally closed, rarely used for activation. Falcon installation issues. The 3 most common installation issues we get calls on. Wiring connections. Too many times the Falcon is wired or powered using the red and white wire. The white wire is for the sensor's common relay output and has nothing to do with powering the sensor. Wiring the red and black wire to power will enable the sensor LEDs and the sensor to function. Number 2, no vehicle only detection. Out of the box, the sensor default settings will detect vehicles and pedestrians. So to adjust the vehicle filter or rejection settings for vehicle detection. We always would recommend to start with the lowest possible rejection setting, which is value 3, and then test it, and you may have to adjust the angle and sensitivity, but start with the lowest possible value. Number 3, the sensor isn't detecting vehicles reliably. That's most likely caused by mounting the sensor off to either side of the door opening. For effective vehicle detection, the vehicle traffic should be coming straight toward the sensor or straight toward the sensor face. In this example, you want to move the sensor to the center of the door opening. Falcon summary highlights. Adjustable detection pattern sizes for ideal door activation, the ability to disregard pedestrian and parallel traffic, provides more precise control of door cycles, different directional detection settings, allows the user to maximize the door's detection zone while reducing HVAC and maintenance costs, unidirectional, bidirectional, and departing detection options. Programmed with signature analysis reduces false cycling due to rain, snow, or extreme vibration. NEMA 4 rated enclosure, rated for splashed water, and explosion-proof enclosure available too, the Falcon EX, and the operating temperature minus 22 to 144 degrees. That's it. Questions you can for customer service, sales, and tech service. Most of you probably have this number, our main number, 800-523-2462. Other questions for BEA Tech Service, if you have technical questions or applications, recommendations on the sensors, you can email this group. There's 5 people in this group that have a lot of knowledge and experience with the sensor and others as well. It's tech_services@beainc.com. A lot of folks use this tool to communicate. It goes to that whole group, and whoever's available will be able to answer your question. Technical documentation literature is found on our website at beasensors.com.